Good afternoon, everybody. It's about time to get started. My name is Brian Poole. I want to thank you all for spending the last hour of your first kickoff day at TechEd coming listen to us talk about deploying ADFS 2.0 in a high availability setting. As you can probably tell, I ran into a little problem this weekend in the form of catching a cold and have been fighting to get my voice back. So rather than subjecting you all to an hour plus of me croaking and cackling and whatever and having my voice sound like this, I'm going to get things kicked off and then fairly rapidly, it sounds like. Well, my original plan was that I was going to keep going for as long as my voice was going strong. It sounds like my voice is already starting to give up. So I'm going to keep going for a little bit, and then I have brought in the other architect from Microsoft IT's Identity and Access Management team, Laura Hunter, who is also expert in our deployment of ADFS 2.0. If you follow her on Twitter, she is at ADFSKidday, and so she is probably one of the best experts around to talk about ADFS, and she is also one of the nicest people in the world who about an hour ago saw the slide deck and said, yeah, I'll help you out, I'll cover for you because I don't want to make those people have to listen to you. So you guys can all thank her whenever she comes up in a minute. So to get started, this is a deep dive on deploying ADFS in a high availability, basically going to be alternating between HA and DR, high availability and disaster recovery. So as we get started, we're going to go through what the basic roles are for ADFS, make sure that everyone's all up to speed for what we're talking about. Then we'll talk about what a high availability deployment topology looks like, and how it's going to work, and some of the tweaks and things and considerations that you need to make whenever you're looking at deploying ADFS in this configuration. Then we'll look at some of the security management operations, best practices, things like that, as we deep dive into ADFS from the server level, the service level, the topology level, to make sure that we can deploy ADFS in a high availability. So the first question is, why bother, right? Who really cares? What if I just deploy ADFS and I get my typical IT 3 nines out of it? Not really high availability, but pretty good. Or 99.5, right? Well, the reason that we care about ADFS's high availability is because ADFS is going to be your link to the cloud. So ADFS is how you get your internal users authenticated to third parties like software as a service providers like O365. It's also how you get your applications the data that they need whenever they're hosted on services like Windows Azure. It's also how you can leverage ADFS for creating applications that are on-prem, just leveraging claims-based authentication. So you can get additional data instead of just AD security groups, and then still have the option of moving that application out to the cloud. The example that I like to give is the way that I think about ADFS is I look at Active Directory. And Active Directory is really the directory service with different services bolted on top of it. Two of the primary ones are your Kerberos head, the KDC, and the NTLM service. Now, those are all in the domain controller. What ADFS is really doing is it's adding the capability to your domain for SAML and WS Federation. So if we think of it like that, as an additional authentication service on top of your domain, then our goal for deploying ADFS is to have availability and performance and redundancy similar to that of Active Directory. Of course, the challenge is that it's not part of Active Directory, and it is deployed as a web service. And so we need to take into consideration, as we're looking at looking at where we're putting the servers and how we're deploying it. I'm sorry, I'm shot here. Ladies and gentlemen, now introducing Laura Hunter. Everyone applaud because she's getting me off the stage. I'm sorry.
Go gargle some salt water or something. Oh. Speaking of water. So hello, everyone. Just because I'm curious, and I like to think this number is going to start going up over time, and also because this is an actual deep dive ADFS session and not intro to the bouncy slide, how many folks in this room actually have ADFS deployed in your I'm so happy. You cannot understand how happy you've just made me, because Brian and I have been presenting on this for years, and we would ask who had ADFS deployed, and typically what would happen is he would ask, and I would be in the audience, raise my hand. He would say, no, you don't count. So I'm happy to see larger numbers. So just to kind of kick things off, based on that show of hands, nobody in this room really needs the bouncy slide, but just as a quick redux, when we're talking about how we're deploying our servers and how we are deploying ADFS as a service, one of the kind of key things that we like to keep in mind is the fact that the traffic and the traffic patterns and how the communications work are largely driven by the client. So there's not a great deal of server-to-server communication between two ADFS infrastructures. There is some, but for the most part, your traffic patterns are driven by the client. So this is the bouncy slide. We've all seen it. We go out to the web server says, stop, I need a token. Client says, I have no idea what you're talking about. Great, go talk to my federation server. Gets to the federation server, hey, I need a token. Great, I need to know who you are. Home realm discovery takes place. We send you off to your home STS. We're going to pretend that your home STS is an ADFS server because, we really like ADFS servers. So great, you're at your home STS. We authenticate you to Active Directory. You get a token. It is signed by the token signing cert of your home STS. We post redirect you back to the relying party STS, rips open the token, pulls out the claims, transforms them, does what it needs to do, creates a new token, signs it with its own token signing cert. We post redirect you back to the web server. The web server can now understand this token because it was signed by the token signing cert of the relying party STS, which is the STS that the application server trusts. All of this communication, point here being, driven by the client. It's all happening via 302 redirects and post redirects that are being driven by the client browser. So when we think about designing the ADFS service for high availability, for disaster recovery, kind of an obvious thing to say, but you want to factor in your high availability plans and your disaster recovery plans. You need to factor these into your service architecture. The last thing you want to do is wake up one day and say, nobody can authenticate to Office 365, because that's really going to be a bad day. I think we realized how critical the ADFS service was going to be for us the day that we realized that O365 was taking a dependency on it. So you think about Microsoft corporate culture. Every once in a while, the power goes out in one of our buildings, because, power sometimes goes out, and it's almost like summer camp, because people will come out of their offices, kind of look out the door, see who's there, and they'll start talking to each other, and it's really cool. So, that's kind of cool. However, we tried to imagine a day where everyone at Microsoft came into work and was told, all of your services work. Power's on, you can get to the internet, you can browse, you can do this, you can do that. All of your services work except for email. The pitchforks and the torches would take about 5 seconds. Because when you think about Maslow's hierarchy of needs, physical security and shelter and blah, 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 the Microsoft iteration of Maslow's hierarchy of needs is first we breathe, then we email. And so we realized that, high availability is going to be very important to our lives. So at a high level, how do we accomplish this? How do we make this happen? I'm an AD person at heart. I always run home to mama when I'm looking for a good analogy. How do you create high availability in Active Directory? Multiple DCs in multiple sites, in multiple data centers. How do you create high availability in ADFS? Multiple ADFS farms, at least two in two different data centers, so you get geo redundancy. You also want to think about high availability for your backend SQL store, which maintains your configuration database. If you're doing things like token replay detection, artifact resolution, SQL Server is a very important portion of your life. So we want to have your SQL store also comprised of multiple clusters located in multiple data centers, mirrored against each other for failover. So broadly speaking, this is the MSIT deployment topology. We have Federation servers, so we have the Federation server role, deployed internally onto our internal corporate network. And then we have Federation server proxies that are deployed out to the internet. So these are internet facing. And what you kind of want to boil down from this is that we have multiple physical farms in multiple physical locations that all effectively resolve to a single logical service. And because ADFS is a web service, it boils down to the DNS name, because that's what's tied to the cert, and that's what's tied to client resolution. So msit.adfs.microsoft.com is the DNS name and is the name that's tied to the certificate for my external facing service, load balanced across multiple data centers. For my internal Federation server services, load balanced across multiple data centers. So we start with the roles. We look at the roles that are comprised within an ADFS infrastructure. We start with the Federation service role, the FS role. The FS role does all the work. This is your security token service. This is the service that maps user attributes to claims, issues security tokens, manages your Federation trust policies, manages your claims rules. This is the STS. Request for security token comes in, request for security token response goes out. Federation server does all the work, FSP gets all the credit, because the FSP is what your clients see if you've deployed the FSP onto your internet-facing infrastructure. So the FSP creates a client proxy for your token requests. Gets to sit out on your extranet, doesn't need to be domain joined, creates an SSL termination point, all good things. Also provides a user interface for your browser-based clients that don't necessarily rely on integrated Windows Auth. So it provides you a mechanism for forms-based authentication for your internet-based clients. Also provides a proxy mechanism to allow for home realm discovery for your internet-based clients. So within MSIT, when we deployed ADFS and we were deploying it across a geolocated infrastructure and being able to meet this requirement of having both internal Federation servers and external Federation server proxies, we had a couple of requirements. Users should always contact their local ADFS instance. I have two physical farms deployed, one in Tukwila, which is in Western Washington State, and one in Dublin. If I have a user request come in from Western Washington State, from Chicago, from anywhere in North America, I want them going to the farm instance that's in Tukwila. My users who are in EMEA, my users who are in APAC, in order to improve the latency experience, I want them going to Dublin. So that's my first requirement. I want my internet users to resolve msit.adfs.microsoft.com to the Federation server proxies. I want my internal users to be able to resolve to the Federation servers, because I want them to have that nice integrated Windows Auth experience that you get by having the Windows authentication endpoint exposed on the Federation servers. And as a part of all this, my proxies also need to be able to resolve to my Federation servers. Which, if you've never deployed the Federation server proxy, creates an interesting scenario. So I have a Federation server proxy. that is configured. Let's just take one box, one of each box, just to simplify. I have a Federation server proxy that is configured as msit.adfs.microsoft.com as its DNS name. I have a Federation server that is configured as msit.adfs.microsoft.com as its DNS name. When the Federation server proxy proxies a request to the Federation server, what does it need to do? It needs to resolve its own name as another server. We'll get to how we do that in just a minute. So this is what our load balancing scenario looks like. And this is how we effected all of those different requirements. So we start with our internet-facing DNS, so my Federation server proxies. We have geographically dispersed DNS, which allows us to meet the first requirement of users must hit their local farm. So users in Tukwila, users in North America, South America are able to resolve msit.adfs.microsoft.com to the Tukwila instance of the farm. Users elsewhere in the world, EMEA, APAC, are able to resolve to their geographically appropriate data center. So that's my first level of load balancing. And then I have hardware load balancers across my multiple nodes within each farm so that I get quick responses to my server failures. And then similarly, I have my intranet servers, so my Federation servers, also load balanced to provide high availability internal to Microsoft. And this can get as simple or as complicated as you'd like it to be. I mean, you can make sure that you have 2 nodes from each farm sitting on different subnets so that you're not facing a failure of a single switch. You can do that. You can choose not to do that. This is one way to slice the onion. It can be as simple or as complex as your HA and DR requirements entail. So now we'll zoom in. We started with the big picture. We're going to zoom in. And what we realized was that, yes, we want to provide all of this high availability and load balancing across multiple nodes of multiple farms, but we also needed to be able to operate this service. We needed to be able to manage this service in a way that if there was a failure, we could reasonably respond to it, and we could reasonably administer the service, and we could reasonably troubleshoot the service. And so kind of the balance that we struck between complexity and manageability is that within each farm, so my 4 Federation servers, my 4 Federation server proxies, we have created 4 individual pairings of FSP to FS. And the way that we solved that little problem I mentioned a second ago of how does the FSP resolve itself to another machine? Host files, baby, they will never die. It's not the only way to solve it. You can do clever things with split-brain DNS if your environment is appropriate, if that is appropriate to your environment. We solved it using host files. Love host files, they'll never die. And so what this does is that this has created for us operational processes for managing a failed Federation server. So let's go left to right. Let's call them FS1, FS2, FS3, and FS4. I have a proxy, FSP1, is tied to FS1 and FS1 only. So when a request comes in across the load balancer, if the client hits FSP1, it will only forward that request to FS1, FSP2, FS2, so on and so forth. What this means operationally is that if any one of my Federation server nodes fails, I not only need to take the Federation server out of the load balancer, I need to take its proxy out of the load balancer because it's a one-to-one relationship. And this is all just part of our operational processes. The biggest reason that we did this was to be able to simplify our troubleshooting so that if we were trying to troubleshoot a client connectivity problem, we didn't have to deal with it came in over the internet, it went to the load balancer, it hit proxy node 1, but then hit another load balancer, and which FS did it go to? Kind of a pain. And so another thing that we've done to aid in troubleshooting is that in all of our ADFS common pages, so our home run discovery page, our forms-based auth login page, our error pages, we have created an ASP.NET line that within the source of the HTML page will echo the name of the server that the user authenticated to. We don't actually print it out to the result in HTML, because that looks kind of lame. But if we have a user who is calling into the help desk, I'm trying to access this Federation-enabled application, and I'm getting these errors, help desk person, and they have scripts, they have help desk scripts that they know to go through this, great. Click on View Source for me, and search for the following. And it gives us a really kind of quick and dirty, easy way within troubleshooting to just home in on exactly which node is causing us problems. So that's kind of cool. So we talked about the proxies, talked about the Federation servers. There's one more piece to the puzzle. And that piece also needs to have high availability configured. And that's your SQL configuration store. And that is the SQL database that sits behind your Federation servers, which stores your ADFS service configuration. It stores your relying party, claims provider trusts, rule storage. If you're doing more advanced things like token replay detection, if you're doing SAML artifact resolution, that data also gets stored to your backend SQL server. And so we want this to be highly available as well. Our SQL mode of operation, so there's like 3 different ways that you can configure SQL for high availability. We have SQL configured in what is called high performance mode. And what that means is that the SQL cluster is performing asynchronous transactions. So I write something to the primary node on the primary node of the cluster. It writes back to ADFS saying, hey, yeah, you're good. And then asynchronously, once the client continues on its way, we'll write the change to the secondary node in the cluster. Trade-off between 100% data resiliency versus perf and usability. This does create a minor risk of loss of data, particularly for token replay and for artifact resolution. If I need to fail over from one node to the other, and for example, an artifact was written to the main node that hadn't yet gotten over to the other node, so minor risk of data loss there, but within acceptable bounds. Does point to the fact that we need low latency between our SQL servers, between our SQL clusters, in order to maintain that consistency of the database. I'm sorry, one more time, please. How does that artifact manifest in practice? So it's a, the question is, how does the artifact manifest in practice? It is part of the SAML spec. So, for example, I think the best way to explain this, so that rather than shooting a bunch of stuff over the wire as part of a token, I'm sorry.
For the end user experience, what is the end user going to see in that situation? Relog on?
Oh, not quite sure the answer to that. Yeah, the application is going to fail in some.
So it would force a retry. There we go. So it would force a retry because what would happen, for example, is the user's authenticated, but via SAML has an artifact GUID. The relying party STS then makes the call back to get the claims, but your ADFS service failed to a different node and doesn't have that artifact anymore. So that would be rejected, and it would be handled on the other side, either as the claims don't exist, throw an error, or the application doesn't get the data that it wanted. It won't be super friendly.
I apologize. I thought you were asking how artifact resolution worked. Sorry, I went a completely different way there. Couldn't find it? Okay, so the question was, how do you define low latency? And the answer is really, really low latency. I couldn't find a SQL admin who would commit to an actual number. So, less than 100 milliseconds. So, land speed is your friend. Excellent. So as we configure SQL to do this high availability and to do this clustering within ADFS, there's two things you got to do, because one would be too easy, and you got to do them in two different ways, because one would be too easy. First thing we have to do is configure the ADFS service host XML config file, which is an XML file that exists, and I've given you the path. I won't bother reading it. servicehost.xc.config, edited in Notepad, edited in Visual Studio if it floats your boat. I have highlighted in red the relevant line. So this is step one. And then you need to repeat the process for the artifact store, so for the artifact resolution store. And we do this in PowerShell. Again, why would you do two things in the same way? That would be no fun. We could edit the XML file in PowerShell. See, I like you. In one line, it would just wrap 17 times. I like you. You're awesome. All right, so we've talked about ADFS from the server perspective. Where do I put my servers? How do I think about where my servers should exist in terms of the services that they offer, in terms of how they become available to my users? So we've talked about it at the server level. Now we think about offering ADFS services from the service level. What is ADFS doing? And at the end of the day, the job of an STS is really simple. Not easy, but it's simple. Requests for tokens come in, tokens go out. Rists come in, risters go out. Again, I'm an AD person. I run home to mama all the time for bad analogies. Feels an awful lot like a domain controller. Authentication requests come in, curb tickets go out. If you like the analogy better, it feels a lot like a certificate server. Requests for certificates come in, certificates go out. In the case of an STS, requests for tokens go in, tokens go out. And when we generate these tokens, there is an entire process within each ADFS server to determine how these tokens get generated. So how these tokens get generated, where this data comes from, what these claims rules look like. And we could actually just spend an entire hour on this slide. If anyone's ever been to the experts conference that Quest puts on every year, we've actually spent an hour on just the claims rule pipeline process. But what it really comes down to is you are mapping business requirements to technical output. Kind of describes a lot of what we do in our jobs, regardless of technology. So when we are outputting claims from an individual ADFS server, the claims pipeline turns into a three-step process. The first thing we do is we accept incoming claims from wherever those claims came from. Could be the claims that came from Active Directory, because this is the user's home STS and this is where the user's been authenticated. Or we could be operating in the federation provider role, and these are the claims that have come from an upstream identity provider. So the first thing we do is we accept the user's incoming claims. Going back to everyone who's ever sat through the bouncy slide, when we refer to the relying party STS, taking the token and ripping it open and looking at all the claims in it to be able to bundle it back up and create a new one, that ripping the original token open and looking at all the claims in it, that's accepting incoming claims. That's the first thing we do. The second thing we do is authorizing the requester. So within the claims pipeline within ADFS, there is a sort of high-level authorization mechanism, operates on a per relying party basis, by which we can determine should the ADFS server even issue a token for this user. So this user has just requested a token for relying party foo, should the ADFS server even issue that token at all? And so that's the second stage of the pipeline. Assuming we determine that, yes, this user should get a token, we then issue our outgoing claims. And this is where the claims transformation portion of ye olde bouncy slide comes in. So I received a claim that's of type group. I want it to be of type role. I've received a group claim that's of value manager, and I want to emit it as a value of purchaser. So this is where like claims transformation comes in. And this three-step process, this three-step pipeline, accepting incoming claims, authorizing the requester, issuing outgoing claims, this takes place on every ADFS server individually down whatever path we have of identity provider to federation provider to relying party STS. So that's generally how these tokens get created and generally how these claims get generated. When we think about how we're managing the service, ADFS, the service, and the service data, a lot of what it comes down to is trust policy management. So how am I actually managing the business policy and the configuration data that is associated with each of my relying parties? Maybe you only have one or two. If you're MSIT, you have 887 at last count. And I didn't even check this morning. The number might be higher. And so what we learned from this, and my friend on my right will be very happy with this, is that PowerShell is your friend. Yes, we get a little applause over there. So when you are managing your relying parties, especially if you're managing them at scale, use PowerShell, not the user interface. Even if you are not operating at scale, even if you only have a couple of relying parties that you need to manage, and really this also applies to claims providers. Even if you only have a couple to manage, I'm still going to tell you to use PowerShell. Because using PowerShell to configure all of your trust policy configuration data creates a very clean and easy and quick disaster recovery scenario if you need to rebuild your ADFS server, your ADFS service from scratch. I need a cert, and I need to rerun my PowerShell scripts, and my ADFS service is back up and running. The way that MSIT learned this was that while we were dogfooding, so while we were dogfooding what would eventually become ADFS 2.0, we would get new builds from the product team fairly frequently, and every once in a while we would get kind of a major minor build in which we were told, yes, you need to drop your SQL database and recreate it as a part of this new build. PowerShell quickly became our friend. Disaster recovery, we don't want to have a single point of failure for anything. Store your copies of your scripts externally from the ADFS server. Otherwise, your ADFS server goes down and your scripts were on your ADFS server. Not a good situation. Here is an example of the PowerShell syntax that is used to create an ADFS relying party trust. So you can see we have we have the identifier, we have the URL of the WSFed endpoint. We have notes, and notes are good, especially if you have 887 relying parties, so that you can at least somewhat remember who it was that you talked to when you set up this relying party trust. Also have your the token lifetime of the RP trust. Here's an interesting little one. I can not only use PowerShell to create my relying party trusts, I can also use PowerShell to create my individual claims rules. So take a claim of type group and emit it as type role. Interesting little nuance between creating rules in the UI versus creating rules within PowerShell. If you create a claims transformation rule within the UI, I think the first screen you get, might be the second screen, the first screen you get is, give this a descriptive name. Transform group to role, whatever. And that's kind of the first thing you get. If you create a rule in PowerShell using the minimum required attributes of the PowerShell commandlet, the name of the rule, when you go to look at it again in the UI, is blank. So that little @ operator becomes your friend. @ rule name equals something descriptive. And then you can see an example of the claims rule language, which actually describes how a particular claims rule will function. Claims sources. So funny little thing that we've realized as we've been managing ADFS over time is that claims management is data management. One might even say claims management is master data management. Or it's at least a subset of it, certainly. So at the end of the day, the reason that ADFS exists as a service and the thing that makes it meaningful as a service is not just that it emits tokens, but that it emits tokens which contain the necessary data to meet your application developers and your application owners' requirements. Sounds kind of obvious. Until you start having conversations with your developers like, I want to be able to restrict this application to only Microsoft full-time employees. I don't want vendors, I don't want interns, I want only full-time employees to be able to access this application. Okay, it's kind of reasonable. How do I do that? And my application developers, they don't work for HR. Some of them know about our human resources data feeds that we get, some of them don't. And more importantly, I don't want to have to expect my application owners to know that they have to come and ask me for, please restrict this application to SAP employee type equals 92. That's kind of the whole reason we do the layers of abstraction, is so that my application owners can focus on writing good apps, I can focus on providing good infrastructure, and my HR folks can focus on providing data integrity of our human resources data. Service-oriented architecture is a good thing even for infrastructure guys. So we think about master data management concepts. Another interesting thing that we've learned is that being a large enterprise, we have examples where data gets replicated across multiple sources. So I have employee type manifests in my human resources database. It also manifests within Active Directory. So I flow information from my SAP database into my Active Directory. Here's the catch. The two are not the same. What do I mean by that? Within my SAP database, I have something like 25 different employee types defined, maybe more than that. Within Active Directory, I have abstracted these down to about 8. Because my application owners and my infrastructure owners' business requirements only really need to have that level of granularity. So over the course of time, we have boiled down 25 or so into 8. Remember when I said I didn't want to have my application developer know that they should come to me and ask for employee type equals 92? I also don't want them to have to care that employee type equals 92 in Active Directory actually equates to employee type equals 90 through 94 from SAP. Data management becomes extremely important when you're dealing with a very flexible application development model where, hey, I don't have to rely on security groups anymore. I can start making authorization decisions on the basis of extremely flexible mechanisms and extremely flexible ways of expressing my data. There's a line from Spider-Man about power and authority and responsibility that I won't bore you with. Back to the HRDA thing, all kind of gets rolled up together, is that I can also emit claims from an ADFS server that come from a SQL attribute store. So I can emit claims from Active Directory attributes. I can emit claims from an ADLDS attribute store. I can emit claims directly from a SQL store. So rather than pulling data from the way Active Directory manifests my employee types, I can just go and get it straight from SAP. I can just go and get it straight from an SAP database. ADFS gives me the ability to do that. But when I'm thinking about a highly available service and a service with a good disaster recovery plan in place, I've got geolocated, highly available this and that ADFS infrastructure from here to, literally across the Atlantic Ocean. But if I only have one instance of a particular SQL attribute store database and it goes down, what have I actually accomplished? So there's your disaster recovery example. Also has kind of an interesting spin when you think about high availability, specifically the way that MSIT has deployed high availability using geolocated DNS. So remember we talked about geographically intelligent DNS so that my users in EMEA will go to the Federation servers in Dublin, whereas my users in Chicago will go to the Federation servers in Tukwila. Well, let's just say that this is a relying party that extracts some of its claims from a SQL database. And let's say that that SQL database is highly available. So I've got 2 clustered instances of that SQL database, so that's good. But it only exists in Redmond. So it only physically exists in Redmond. Think about what that means when a user from Europe goes to authenticate to an ADFS-enabled application that relies on this SQL store. Go to the web server, go get me a token, go dance through the whole bouncy slide. Great, let's start issuing you that token. msit.adfs.microsoft.com. You just went to Dublin. First claim rule, go get some stuff out of Active Directory. Great, I've got DCs in Dublin. I've got DCs and data centers all over the place. Great, so that second request goes to Dublin. Third request, so third claim rule, go get me some information out of this SQL store. That's over in Redmond, which means that my brilliant plan to provide low latency for my EMEA user, well, guess what? Now he's bouncing all the way across to Redmond and back. And what if I have 5 claim rules in a row that each call this same SQL server? All of a sudden, I'm bouncing and I'm bouncing and I'm bouncing and I got latency all over the place. What is the answer to this? Is the answer to this that we mandate that all of our attribute stores provide geolocation? Maybe. Or maybe we ask nice because, I can't exactly make another group go spend money. Sometimes I can't even make my own group go spend money. Is the answer that we work on our claims rule logic so that, yes, I need to go get data from this database that, at least for the next 2 quarters until they have budget for geo-redundancy, is only going to exist in Redmond? Well, great. Maybe I can take those 5 claims rules and smoosh them down into 1. So yes, maybe I'm still making a call across the Atlantic to go get this data, but I only have to do it once instead of 5 times. Right and wrong answers, art versus science. Things to think about. Custom attribute stores. So we've talked about being able to source claims data from Active Directory, ADLDS, SQL. These are the 3 things that you get out of the box with ADFS. This is what it ships with. This is what it lets you do largely point and click through the UI. There's some cases where you're going to have to be manually creating ADFS claims rules, but for the most part, this is what you get out of the box. AD, ADLDS, SQL. You can also extend ADFS to obtain claim values from a custom source. So I want to call a web service that's going to do some custom thing that ADFS does not do out of the box that will return claims data. You can do this using a custom attribute store. And when I say custom, I mean custom. You are opening Visual Studio and typing. The limits of what you can do with a custom attribute store are constrained by the limits of your .NET Developer Mojo. It's all written in .NET. Anything that compiles in Visual Studio, you can use to write a custom attribute store. C#.NET, VB.NET. I have no religion. And it implements a single predictable interface. It implements the iAttribute store interface. And what happens is that you create an attribute store that ADFS will make a call to using some defined parameters. Typically, I mean, think about something like, I'm going to send the user's name, email address, and the name of the relying party to this web service, and it's going to return the roles that this user has within this application. Centralized authorization, it's gonna be big. So you have this custom attribute store that's going to return one of 4 possible values, 3 of which are errors. It's either going to return a 2-dimensional array of claim type, claim value, or it's going to return one of 3 errors, kind of self-documenting: store query exception, store query format exception, store invalid configuration exception. The thing that we've learned as we've worked with custom attribute stores over time is that they always need to return something, or else your user's experience when they go to access this relying party is going to be rather unacceptable. Because if the custom attribute store returns nothing, then that claim rule is just going to hang and hang and hang, and eventually it'll give up. But by that time, your users have already called the help desk and complained that ADFS is down, and the world is falling. The world is falling apart. So, kind of the practice that we've taken is within MSIT is for a custom attribute store, we mandate that our application developers code their attribute stores such that if the data store that's being called is not available, so I'm calling out to a web service and the server that's hosting that service is down, I want the custom attribute store to return a value, to still return a value. It has to return something, but I want it to return a value indicating that it couldn't get those claims. So thematically, it's almost like the point that you made earlier of what happens if I go to get that artifact and that artifact is not there. Thematically, it's kind of similar to that, because what we're mandating is that applications receive an error message, something to the effect of, yes, authentication was successful, and we are returning a valid token because you did authenticate against this ADFS server, but we couldn't get you all the claims that the application needed. And now it's up to the application to fail in a meaningful and intelligent way. This is where the SOA thing gets fun, because we have faith in our application developers that they do the right things. What else have we learned? So claims provider rules, when we're defining rules on a claims provider trust. So we've been talking a lot about relying party trusts. Now let's switch gears and talk about a claims provider trust. So this is defining the claims that will be issued or transformed from a user who is authenticating from an upstream identity provider. Could be a separate STS, or it could even just be Active Directory, because you can define a set of claims provider rules for Active Directory as a claims provider. When you define a rule on a claims provider trust, that rule applies to every single user who authenticates using that claims provider. Kind of sounds logical when you say it out loud, until you think about the relying party application that wants to attach a custom attribute store to the Active Directory claims provider trust. And suddenly, if their custom attribute store goes down and doesn't fail in that meaningful way where it still at least returns something, my Active Directory authentication requests start failing for every single relying party on my server. As the owner of the infrastructure service, this is not acceptable to me. One application owner cannot have that much power over my entire service. Other data management things, naming standards for claim types are good, obviously. In other news, the sun rose in the east this morning. Publishing claim types in Federation metadata. So this is very much your friend. You want to be sure that the Federation metadata, the claim types that you are publishing in Federation metadata, in that Federation metadata.xml file, you want to be sure that these claim types are actually meaningful and actually map to the claim types that you are publishing. The reason I call this out is because there's not necessarily an intuitive way within the ADFS management console for you to notice if they get out of sync. Like, there's not going to be a big red button flashing that says, hey, you're still publishing in your Fed metadata like the 8 default claim types, and number 1, you're not actually issuing those to any of your RPs, and number 2, you're issuing like 20 other claim types that you haven't published to metadata yet. There's not a big red flashing button that will tell you that you're doing that. Master data management is, as they say, an exercise left for the user. But it is an important exercise. Security best practices. Talked about the server, talked about data management, talk about securing our ADFS infrastructure. Kind of the first, best, and easiest advice I can give you when talking about securing your ADFS infrastructure is that the ADFS server role integrates with the server configuration wizard. That really cool thing that first shipped in 2003 SP1 that will go through and automatically lock down the right ports for you and kind of do all of that goodness. This is where we start. This is where we start our security configuration. Other things that we think about for securing ADFS as a service, we think about token lifetime. And each application, each relying party has a configurable token lifetime for the tokens that get issued to that application. Again, running home to the Active Directory analogies, this is kind of configurable. This is kind of comparable to the service ticket within Curb. And you can configure on an application level how long that token should stay alive for. And that's when you start thinking about security policies that map to not just application security, not just service security, but data security. Because some requests that we get in have been things like, this is a low business impact application. I'm publishing things like the menu in the cafeteria in Red West this week. Yes, I would still like that application to be authenticated, but do I really want to reprompt my user for creds once an hour? That seems a little on the draconian side. But if I'm talking about things like source code access, if I'm talking about things like HR data, 401k, financial information, then yes, that data is sufficiently important to me that I want to secure it in the corresponding way. Also want to think about enforcing lifecycle management on relying party trusts, on identity provider trusts. And this is thematically similar to application lifecycle management for any technology. The processes needed to turn on an application, to turn on a service. Any IT enterprise is going to have processes involved and processes defined for how you do that. You have to call IT to get this DNS name configured. You have to call the firewall guys to get this, this port opened on the firewall. In the case of ADFS, you have to call my ADFS operations engineers to create a relying party trust and to configure that relying party trust on the ADFS infrastructure. That's how you turn it on. How do you turn off an application? You turn off the server and you walk away. So I talk about how we have 887 relying party trusts configured. At one point that was up over 1,000 until we started doing data mining on our IIS logs to figure out which ones were still in use, and we realized that the RP called Joe's test Azure POC app.cloudapp.net actually only got used for like 2 weeks while the guy was trying to figure something out, and then it never got used again. So we've implemented processes around if your app gets no hits for the space of 6 months, we fire off an email to the application owner. We don't want to just go arbitrarily turning things off because there are things like HR applications, there are things like financial applications that users will legitimately only access once a quarter or once every 6 months. So lifecycle management's a good thing. Design an elevated admin access model. This one is very interesting. So this is something that we've worked on very hard, and I think all of us have worked on very hard in the Active Directory space and in the CA space, which is your domain admins have the keys to the kingdom. Let's make sure that, domain admins can only log on to the DCs using a separate account with a smart card and blah, 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 blah. You know how you administer an ADFS server? You get to be a local admin on the box. And that's it. In terms of what the product gives you for restrictions, that's pretty much what you've got. So you fall back to process, and you fall back to training your admins in the way that they should go. Other security best practices. Privacy of PII information. Just because an application owner says that he wants you to emit social security number as a claim type in his application doesn't mean you shouldn't tell him to go jump in a lake. Here's an example. We talked about how kind of your first and best friend where securing ADFS is concerned is the server config wizard. This is an example of the syntax that's needed to secure kind of the default configuration for a standalone ADFS server that's using WID, that's using the Windows Internal Database, an ADFS server in a farm config that's using WID, or an ADFS server in a farm config that's using SQL as its backend rather than WID. There's also an option for the Federation server proxy in order to secure that default configuration. And this is an example of what the actual config information within SCW looks like in terms of what it's going to do to the services and how it's going to configure those services by default. So moving along, we've talked about securing the service, talked about data management. The service is up and running, and at the end of the day is costing management money to run, unless you have found the tree upon which money is grown, in which case come talk to me after. And so one of the things that we want to be able to do, rather important thing we want to be able to do, is to be able to advertise and report on the usage of the service. How many RPs do I have? How many RPs do I have that have had an authentication hit in the last 6 months? How many times did Redmond Whack Bill G authenticate to something in the last 6 months? And this is how we do that. Within IT, we use SSRS because SQL is our friend. We have SSRS reports that will view our data in kind of meaningful and interesting ways. The way that we collate that data for SQL is we use the log parser tool. How many people have heard of log parser? Lots of people, very happy. This was like the coolest tool ever. It was like this, I don't know, it was like this skunkware tool that got released in the Server 2003 resource kit, and somebody realized it was like the neatest thing ever. I actually contributed way back in the day. I actually contributed to a book on it because everyone realized that, oh my God, it's this awesome tool and this community grew up around it. So that's what we use. We use log parser to collect the W3 SVC events on our ADFS servers because at the end of the day, ADFS is a web service. So we trawl our IIS logs. This information is only generated for passive federation. Is the only downside. So if you're using active clients, this approach does not necessarily work for you. So we use log parser to collate all of that data. We use SQL Sprox to parse the data reasonably and push it into SQL, and then we throw reports up into SSRS. I'm sorry? Is there a management pack? Yes, there is. Yep, SCOM management pack. We'll actually talk about that in a couple of minutes. So troubleshooting. Troubleshooting Active Directory Federation services. For those of you who haven't heard me say this before, It's simple. It's either PKI or it's a typo or it's PKI. Unfortunately, your users get a little fidgety when you tell them that. So in order to try to assist in the troubleshooting process, what ADFS2 will do is that every error that gets generated by an ADFS server, a reference number gets issued. You can see the little GUID up there, 469, blah, blah, blah. In the default error page that ships out of the box with ADFS 2.0, you will get exactly what you're seeing up on the screen. Oops, something went wrong. I don't know what to do. Call your sysadmin, and here's the reference number. And I would actually recommend, even if you customize your error pages, you do like nice, pretty graphics and branding on them and whatnot, I would absolutely still expose this information to your users, because it will be just the living end of you for troubleshooting if you don't have anything to go on other than, yeah, I tried to access this and it didn't work. Having this GUID available to you makes it incredibly easy to parse through and trawl through your ADFS logs on your various servers to find the appropriate event to see where something failed. And I have given to you, because I care about your time and well-being, I have given to you the PowerShell snippet that allows you to do just that. Okay, technically Brian gave it to you and I'm sitting up here reading the slide. But I'll take credit for it anyway, because, you know, I'm the one on the soapbox. Availability and monitoring. It's like your prescient. For internal monitoring, we use the SCOM management pack. Talks about server availability, talks about service health. Something else to think about is external monitoring. So the SCOM management pack is very good from a service health perspective, but you also want to think about how your service looks to your users. And so you want to think about things like, if the server is up and the server is running, but my edge router failed, so none of my internet-based users can auth to an application, I still have a problem. And the SCOM management pack will not, at least innately, will not capture that for me. I can do correlation across the ADFS management pack versus my networking management packs and all those other good things. But innately to the service, you want to think not only about the health of the service intrinsically, but how the service is presenting itself to your end users. You want to be able to verify end to end all the way through all of the network layers, particularly when you're in a scenario such as the one MSIT uses, where we have this complex Jenga game of DNS records and network load balancers and geo-redundant DNS. So, in summary, first of all, in summary, I'm so glad that so many people in this room are using ADFS. It just warms my heart. And so now that we're running ADFS, we want it to be highly available for our customers. And yeah, you can do that. And it's a web service. So at the end of the day, the way that you provide HA for ADFS is thematically similar to the way that you provide HA for any other web service. Your SQL configuration is crucial. You're going to be spending some money to do it right, depending on the size of your infrastructure, because you're dealing with multiple farms across multiple geodiverse data centers. IIS logging, log parser, SQL reporting services are your friends. PowerShell is your best friend in the whole wide world. And configure monitoring for your service, not just for the health of the service within its little constrained circle, but for what the health of the service looks like from end to end. Track resources, other resources. Go fill out a something and win a Connect. I love my Connect. You so got to win a Connect. And thank you very much. Please fill out your evals. Have a wonderful evening.